Hello everyone and welcome to this module where we begin our discussion on angular projection. Now in our previous video series we discussed projectile motion, but we were talking about horizontal projection. From this module onwards we will start our analysis of angular projection. So just to recap, I first want to give you an introduction of what angular projection is like. Now if I talk about projectile motion in which I have an angular projection, what does the motion look like? So here you can see that if I project an object with an angular projection, that's what its motion looks like. So what is the difference? You can see for yourself that angular projection means that initially when the object is projected, it is projected at some angle with the horizontal. In comparison, if I draw a picture of horizontal motion, you will remember that in that case, I projected the object with some horizontal velocity. So you see the difference. Here the velocity is completely along the x-axis and here it is at some angle to the x-axis. And therefore, this is the difference. This was horizontal projection and this is angular projection. So now let's tackle angular projection. Now we will tackle it in the same way that we tackled horizontal projection. What we did was that we will analyze the x-axis motion separately and the y-axis motion separately and then combine the two to get what is the combined effect of these motion. So here if I take a look at the initial point of projection O, I have an initial velocity u which I have given to the object while throwing it. Now this velocity u has two components, one along the x direction and one along the y direction. And why do we want to resolve it into two components? Because I want to study the x-axis motion separately and the y-axis motion separately. Now I want to study this motion, so I say that at some point let the object be at some point P. At some point in time, the object has reached this point P. I will say that this object initially had some velocity u. This initial velocity u I will resolve into two components, that is u cos theta and u sin theta. So here I can see that the x component is u cos theta and the y component is u sin theta. Keep in mind these are the initial values of the velocities along the x and the y direction. So what exactly is happening along the x direction? Along the x direction, I say that the horizontal component of velocity, which is u cos theta, remains constant throughout. And why am I saying that the horizontal component remains constant throughout? Because there is no accelerating force in the horizontal direction. Now, remember, what is the definition of projectile motion? It means once you project the object, it is moving only under the effect of gravity. And in which direction is gravity acting? Along the y direction. Therefore, if I take a look at this motion and I see, is there any force acting along the x direction? There is no force acting along the x direction, and because of that, the velocity along the x direction will not change. So we have drawn our first conclusion about angular projection, that is, the velocity along the x direction does not change. So initially the velocity was u cos theta, which we found. That means at any point in the motion, the velocity will always be u cos theta along the x direction. Now let's see what happens along the y direction. The vertical component of velocity, which is u sin theta, it's saying that it decreases continuously with height. That means when the ball goes from this point to any point in its motion, its velocity is changing. So can you imagine why this is happening? Well, at this point, that is the initial point, the vertical velocity of the object is u sin theta. So u sin theta is the initial vertical velocity of the object. And they are saying that this will decrease continuously with height. That is when it will go from 0 to h. That means when the object will go from 0 to h, h is the highest point in its motion. So when this object goes from 0 to h, the velocity is decreasing. Now you can understand this intuitively. When I throw an object up, gravity is pulling the object down. So as the object goes up, its velocity will continuously decrease. So from u sin theta at this point, the velocity decreases till when it reaches the highest point in its motion. What will be the vertical velocity at the highest point in its motion, the vertical velocity will be 0. So, let me recap. If you take a look at this object at the highest point in its motion, you will see that they have only written u cos theta and it is only in the horizontal direction. And why is that? We said the horizontal velocity will not change. So, even at some later time t, the horizontal velocity is still there, that is u cos theta. But what happened to the vertical velocity? Initially, it was u sin theta. It went on decreasing, decreasing, decreasing. And at the highest point, there is no vertical velocity. All the velocity is only horizontal. Okay, so at the highest point, the vertical velocity is 0. Now, from this point onwards, up to the point it reaches back on the ground, the vertical velocity will again increase. And then this velocity will again increase from 0 and it will keep on increasing till the object reaches the ground again. What are the two main conclusions? The two main conclusions are that initially, if the object is projected with some velocity u, you will break this down into u cos theta, which is the x direction velocity, and u sin theta, which is the y direction velocity. And what you must remember, that is the two conclusions, is that the x direction velocity, that is the horizontal velocity u cos theta, does not change throughout the motion, it's constant, whereas the vertical velocity u sin theta changes, it decreases as you go from the initial point to the highest point, and then it will increase from the highest point to the initial point again. And therefore, I say that at the highest point, there is no vertical velocity, only horizontal velocity is present, which is u cos theta. Finally, I just want to give you some terminology. I say that this height, that is the maximum height that this object attains in its motion, is known as maximum height. And this horizontal distance that the object moves along its motion, that is from the initial point of projection to the point it comes back to the ground, this horizontal distance is what we call as horizontal range. So these are the terms that I want you to be familiar with. And this is the introduction of angular projection that I wanted to give you. So thank you for watching our introductory video on angular projection. If you like our channel, you can subscribe to it by clicking here. And if you'd like to buy your very own target book, you can click here and go to the page where you can buy it for yourself. Keep watching and stay tuned for more videos.